LangGraph implements hierarchical state management through nested subgraphs, where each level maintains isolated state schemas while enabling controlled data flow between parent and child components. This architectural pattern facilitates modular composition, allowing complex workflows to be decomposed into self-contained subgraphs with well-defined interfaces. The implementation demonstrates a three-tiered hierarchy: grandchild, child, and parent graphs, each with distinct state schemas and transformation logic. You'll observe how state isolation is enforced at each level, while explicit transformation functions bridge the communication gaps between nested components, with the parent graph orchestrating the overall execution flow through strategic node placement and edge connections.
#grandchild graph. From typing extensions, import type dict. From LangGraph, graph state import state graph start end. Class grandchild state type dict. My grandchild key, str. Def grandchild one state. Grandchild state. Hash note, child or parent keys will not be accessible here. Return my grandchild key. State my grandchild key. How are you? Grandchild equals state graph grandchild state. Grandchild, add node grandchild 1, grandchild 1. Grandchild add edge start, grandchild 1. Grandchild add edge grandchild end. Grandchild graph equals grandchild compile. #child graph. Class child state type dict. My child key, str. Def call grandchild graph state, child state. Hash note, parent or grandchild keys won't be accessible here. Grandchild graph input equals my grandchild key. State my child key. Grandchild graph output equals grandchild graph. Invoke grandchild graph input. Return my child key. Grandchild graph output my grandchild key, plus today. Child state graph child state. We're passing a function here instead of just compiled graph. Grandchild graph. Child add node child. Call grandchild graph. Child add edge start. Child 1. Child add edge child. End. Child graph equals child compile. #parent graph. Class parent state type dict. My key, str. Def parent 1 state. Parent state. Hash note, child or grandchild keys won't be accessible here. Return my key. Hi plus state my key. Def parent 2 state. Parent state. Return my key. State my key plus by. Def call child graph state. Parent state. Child graph input equals my child key. State my key. Child graph output equals child graph. Invoke child graph input. Return my key. Child graph output my child key. Parent equals state graph parent state. Parent add node parent 1. We're passing a function here instead of just a compiled graph, child graph. Parent add node child, call child graph. Parent add node parent 2. Parent add edge start, parent 1. Parent add edge parent, child. Parent add edge child, parent 2. Parent add edge parent, end. Parent graph equals parent compile. For chunk and parent graph, stream my key. Bob subgraphs equals true. Print chunk.
This code demonstrates a hierarchical graph architecture with 3 levels of nested subgraphs, each maintaining strict state isolation. The pattern shows how to compose complex workflows by encapsulating functionality at different abstraction levels while preventing unintended state sharing between layers. At the implementation level, each graph defines its own typed dict state schema with distinct keys, and communication between levels happens through explicit state transformation functions. The grandchild graph processes its isolated my grandchild key. The child graph transforms this into its my child key context, and the parent graph manages the top-level my key state. This design enforces clear boundaries between concerns while allowing controlled data flow through the hierarchy. The streaming output reveals how LangGraph handles nested execution, showing intermediate states from all levels when subgraphs equals true is specified. This approach is particularly valuable for multi-agent systems where agents need private state spaces while contributing to a shared workflow. The trade-off is increased complexity in state management, as each layer requires explicit transformation logic, but this is justified by the improved modularity and isolation guarantees. Let's break it down.
From typing extensions, import type dict.
Imports typed dict from typing extensions for creating dictionary types with static type checking.
From LangGraph, graph state import state graph start end.
Import state graph, start and end from the LangGraph, graph state module. State graph is a class for defining stateful graphs, while start and end are constants representing the entry and exit points of a graph.
Class grandchild state type dict. My grandchild key, SDR.
Defines a grandchild state class that inherits from typed dict with a single required string field named my grandchild key. This creates a type-hinted dictionary structure where the key, my grandchild key, must be present with a string value.
Def grandchild one state. Grandchild state, grandchild state. Hash note, child or parent keys will not be accessible here.
Defines a function named grandchild1 that takes a grandchild state object as input and returns a grandchild state object. The comment indicates that within this function, keys from parent or child states won't be accessible, suggesting this operates in an isolated scope limited to its own state.
Return my grandchild key. State my grandchild key. How are you?
Returns a dictionary with a single key, my grandchild key, whose value is the current value from state, my grandchild key, concatenated with the string, how are you? This operation creates a new dictionary rather than modifying the existing state.
Grandchild equals state graph grandchild state.
Creates a new state graph instance named grandchild that operates on the grandchild state type. This initializes a graph structure that will manage state transitions and workflows specific to the grandchild state type, though no nodes or edges are defined in this line.
Grandchild, add node grandchild1, grandchild1.
Adds a node named grandchild1 to the graph referenced by the grandchild object, associating it with the grandchild1 function or object. This establishes a processing step in the graph's workflow under the identifier grandchild1.
Grandchild add edge start, grandchild1. Grandchild add edge grandchild end.
Adds two directed edges to the grandchild graph. The first edge connects the start node to a node named grandchild1. The second edge connects grandchild1 to the end node. This creates a linear path through the graph. Start right arrow, grandchild1, end.
Grandchild graph equals grandchild compile.
Calls the compile method on the grandchild graph object, which processes and optimizes the graph structure into an executable form. The compiled result is then assigned to the variable grandchild graph for later use. This is a standard step in LangGraph to prepare a graph definition for execution, though the specific optimizations or transformations applied during compilation aren't visible in this line.
Class child state type dict.
Defines a child state class that inherits from typed dict, indicating it will be a dictionary-like structure with type annotations for its keys. This establishes a type-safe container for state data, where each key's value type can be explicitly declared when the class is fully defined. The segment itself doesn't specify any fields yet, It only declares the class structure will use typed dictionary semantics.
Def call grandchild graph state, child state, child state.
Defines a function named callGrandchildGraph that takes a parameter state of type child state and returns a value of type child state. The function signature indicates it processes a child state and returns a modified or new child state, but the implementation details aren't visible in this segment.
Grandchild graph input equals my grandchild key, state my child key.
Creates a dictionary named grandchild graph input with a single key, my grandchild key, mapped to the value from state my child key. This extracts a value from the current state and repackages it under a new key for use in a nested graph context.
Grandchild graph output equals grandchild graph. Invoke grandchild graph input.
Invokes the grandchild graph with the provided grandchild graph input and assigns the resulting output to the variable grandchild graph output. This is a direct method call where the graph processes the input and returns its output, which is then stored for potential later use. The line demonstrates a straightforward execution of a graph instance with a given input.
Return my child key. Grandchild graph output my grandchild key, plus today.
Returns a dictionary with a single key, my child key, whose value is the string from grandchild graph output my grandchild key, concatenated with the literal string today. This transforms the grandchild's output by appending a question suffix, creating a new derived value in the parent graph's output structure.
Child state graph child state.
Creates a new state graph instance named child that operates on a state type child state. This initializes a graph structure that will manage state transitions and workflows specific to the child state type, though the exact state definition and graph configuration aren't visible in this line. The child variable now holds this graph instance for further configuration or execution.
Hash, we're passing a function here instead of just compiled graph, grandchild graph. Child add node child, call grandchild graph.
Adds a node named child1 to the child graph that will execute the callGrandchildGraph function when invoked. The node is configured to call this function rather than directly using a compiled graph object, allowing for dynamic behavior or additional processing before invoking the grandchild graph.
Child add edge start, child1.
Adds a directed edge from the start node to the node labeled child1 in the child graph. This establishes a connection where execution can flow from the starting point to the child1 node.
Child add edge child, end.
Adds a directed edge from node child1 to the end marker in the child graph, establishing a termination path that signals completion when child1 finishes execution.
Child graph equals child compile.
Calls the compile method on the child graph object, which processes and optimizes the graph structure into an executable form. The result is stored in the variable child graph, representing the compiled version of the child graph ready for execution. This is a standard step in LangGraph to prepare a graph for running, though the specific optimizations or transformations applied during compilation aren't visible in this line.
Class parent state type dict.
Defines a parent state class that inherits from type dict, establishing a type-hinted dictionary structure for representing state data in a type-safe manner. This creates a foundation for structured state management where keys and value types can be explicitly declared, though the specific fields aren't visible in this single line. The inheritance from type dict indicates this will be used for runtime type checking and IDE support rather than being a traditional class with methods.
Def parent one state, parent state, parent state.
defines a function named parent1 that takes a single parameter state of type parent state and returns a value of the same type parent state. The function signature indicates it processes or transforms the input state and returns a modified or new state object, but the implementation details aren't visible in this segment.
Return my key. Hi plus state my key.
Returns a dictionary with key my key, whose value is the string hi concatenated with the current value of state my key.
Def parent2 state. Parent state parent state.
Defines a function named parent2 that takes a single parameter state of type parent state and returns a value of the same type parent state. The function signature indicates it processes or transforms the input state and returns a modified or new state object, but the implementation details aren't visible in this segment.
Return my key. State my key plus by.
Returns a dictionary with key my key containing the current value from state my key concatenated with the string by. This modifies the existing state value by appending additional text before passing it forward in the graph execution.
Def call child graph state. Parent state parent state.
Defines a function named callChildGraph that takes a single parameter state of type parent state and returns a value of the same type parent state. The function signature indicates it's designed to process some parent state and return a modified or updated version of that state, likely for use in a graph-based workflow where child graphs need to interact with parent graph state.
Child graph input equals my child key. State my key.
Creates a dictionary named childGraphInput with a single key, my child key, mapped to the value from state my key. This extracts a specific value from the current state and prepares it as input for a child graph, using a different key name in the child context.
Child graph output equals child graph. Invoke child graph input.
Invokes the child graph with child graph input as input and assigns the resulting output to the variable child graph output. This is a direct execution call where the graph processes the provided input and returns its computed result.
Return my key. Child graph output my child key.
Returns a dictionary with a single key, my key, whose value is extracted from the my child key field of the child graph output dictionary. This operation maps or transforms the output from a child graph into a parent graph's expected format by selecting and renaming a specific value.
Parent equals state graph parent state.
Creates a state graph instance named parent using parent state as its state type. This initializes a graph structure that will manage state transitions, with parent state defining the shape and type of the state data that flows through the graph.
Parent add node parent, parent1.
Adds a node named parent1 to the graph, associating it with the parent1 object. This registers the node within the graph structure, making it available for connections and execution in the workflow.
Hash, we're passing a function here instead of just a compiled graph, child graph. Parent add node child, call child graph.
Adds a node named child to the parent graph that will execute the callChildGraph function when invoked. The node is registered with the identifier child and will call the provided function rather than directly referencing a compiled graph object.
Parent add node parent, parent2.
Adds a node named parent2 to the graph using the parent2 object as its implementation. This registers the node within the parent graph structure, making it available for execution and streaming operations.
Parent added start, parent1.
adds a directed edge from the start node to the node named parent1 in the graph structure managed by the parent object. This establishes a connection where execution can flow from the starting point to the parent1 node.
Parent add edge parent, child.
Adds a directed edge from node parent1 to node child in the graph structure. This establishes a parent-child relationship where parent1 is the source node and child is the target node, enabling data flow or dependency tracking between these nodes in the graph.
Parent add edge child, parent2.
Adds a directed edge from the node named child to the node named parent2 in the graph structure. This establishes a parent-child relationship where parent2 becomes a parent of child, enabling data flow or dependency tracking between these nodes in the graph.
Parent add edge parent, end.
Adds a directed edge from node parent2 to the end node in the graph structure, establishing a termination path for workflow execution.
Parent graph equals parent compile.
Calls the compile method on the parent object and assigns the result to parent graph. This operation likely transforms the graph definition into an executable form, though the specific behavior depends on the framework's implementation.
For chunk and parent graph, stream my key. Bob subgraphs equals true.
Iterates through a stream of chunks from parent graph stream, passing a dictionary with key, my key, and value Bob as input. The subgraphs equals true parameter ensures the stream includes outputs from both the parent graph and any nested subgraphs, enabling real-time updates from the entire graph hierarchy. Each iteration processes a chunk of streaming data as it becomes available.
Print chunk.
Prints the value of the variable chunk to the standard output. This is a simple debugging or logging statement that displays the current content of chunk during execution. The output will appear in the console or terminal where the script is running. This implementation showcases LangGraph's hierarchical state management through a three-tiered architecture, where each level maintains strict state isolation while enabling controlled data flow. The grandchild, child, and parent graphs each define their own typed dict state schemas with distinct keys, enforcing clear boundaries between concerns. Communication between levels happens through explicit transformation functions that map state values between different schemas, with the parent graph orchestrating the overall execution flow. The design pattern demonstrates how complex workflows can be decomposed into self-contained subgraphs with well-defined interfaces, where each level processes its isolated state while contributing to the broader workflow. The streaming output with subgraphs equals true reveals how LangGraph handles nested execution, showing intermediate states from all levels. This approach is particularly valuable for multi-agent systems requiring private state spaces while participating in shared workflows, though it introduces complexity in state management that's justified by the improved modularity and isolation guarantees.
The grandchild whispers to a key. The child locks it away. Yet the parent unlocks nothing. State flows through invisible doors.